Let's take a look at geometric sequences now. A geometric sequence is a sequence of numbers in which each successive term is found by multiplying the previous term by a particular number called the common ratio. So this is where we're looking at sequences where you get the next number by multiplying by something. And yes, it's always in terms of multiplying. Even if it's getting smaller, we're going to still look at it as what are we multiplying each term by. And that's called a common ratio. So for example, this geometric sequence goes 1, 2, 4, 8, and we could keep going with this, but what we're doing is we're multiplying by 2 each time. So in this case, my common ratio is 2. Whereas here we have 32, 8, 2, 0.5. And I know your first instinct would be to say that we're dividing by 4, but we don't write our common ratio that way. It's always in terms of multiplication. So if you figure out, oh, we're dividing by 4, then you must actually be multiplying by 1/4. So notice it's just 1 over whatever number that you figured out. So 1/4. 1/4. So my ratio here is 1/4. These are not geometric sequences, 2, 6, 10, 14. This one's actually arithmetic because we're adding 4 each time. This one is 1, 4, 9, 16. Oh, I see a pattern. This one is +3. This one's +5. This one's +7. So the next one would be +9 and so on. But it's neither arithmetic nor geometric because we don't have a common number that we're adding every time or subtracting every time, and we're not multiplying by the same number every time. So just like before, we're going to talk about some notation and formulas. Our first term is still going to be that A value, that letter A, but now your common ratio is going to be R. So difference was D, ratio is R. I think that kind of makes sense. So our first term would be A, and then our second term would be, so actually let me grab this 1, 2, 4, 8, ... So our second term is 2, our third term is 4, our fourth term is 8, and so on. To come up with a general formula, this is going to be our new formula that we're going to use. So Tn equals AR to the n minus 1. So again, you may want to write that down somewhere. In this case, A is 1. So A is 1. R is, so we know that we're multiplying each of these by 2. So R is 2. And I like to put the 2 in brackets just so it doesn't look like the number 12. And then to the n minus 1. And we can just leave it like that. So there's no simplification here like there was with the arithmetic. We're just going to leave it exactly like this. You cannot multiply that number inside the brackets because remember, order of operations tells us we actually have to evaluate the base to the exponent first and then do the multiplication. Okay, so determine expression for the general term and then find t to the 7. So let me just pull out my formula here again to help us. All right. So I need my a, which is 2, first term 2, and then it goes 2, 6, 8. So I'm multiplying each time by 3. So r is 3. So my expression then would be Tn equals 2 times 3 to the n minus 1. And if I wanted to find T7, that just means I'm going to put a 7 in for the n. So 2 times 3 to the 6. In my calculator, I'm going to work out that 3 to the 6 first. And I get equals, and then times that by 2. I get 1, 4, 5, 8. My 7th term would be 1,458. Try one more. Oh, I like this one. Okay, so we have 8 and 4.8 and 2.8. So this one, we can tell our A value. Our A value is at 8. Now finding our R value, that's a little bit harder. So let's take a look here. So it's a ratio, which means we're multiplying by the same thing. So actually, if this were in a table, I could start. So we can find our R value simply by taking the term and dividing it by the term in front. And so in which this case is 2.88. And if I divide that by in front, I'm going to divide it by 4.8. And so 2.88 divided by 4.8, and I get 0.6. Now I'm just going to double check to make sure. So 4.8 divided by 8, 4.8 divided by 8, and yes, I do. I get 0.6 again. So that means my R value must be 0.6. And so if I now write my Tn, I have my A value, I have my R value, so Tn equals 8, bracket 0.6, bracket to the n minus 1. And lastly, it asked me to find T17, so 8, 0.6 to the 17 minus 1, so 8 times 0.6 to the exponent 16, so 0.6 to the exponent 16 equals, and then times that by 8, still a teeny tiny number, 0.002, if I round. Okay. So if you can't identify your ratio, you can find it simply by dividing one number in front of the other, and then that will give you your R value. Determine the number of terms. So we're trying to look for n. All right, so what can I pull out of here? Well, I can pull out my A value, which is 5. I can pull out my R value. I can see that we're multiplying by a -2. And I can actually see my last term, my Tn, which is -10240. So if I put that into my formula, this is what I get. Okay, so let's start by dividing by 5, dividing by 5. So 10240 divided by 5, and that gives me -2048 equals -2 Bm minus 1. All right, so let's change this so that it's a base of -2. So this number is the same thing as -2 to what exponent? So I'm going to have to play a little bit with my calculator. So -2 times -2 times -2 times -2 times -2. So that's 5. Let's do 6, 7 times. I can only get -128. So let's keep going. 8 times brings me to 256. 9 times gives me -512. 10 times gives me 1024. 11 times. So there I am. -2 to the exponent 11 is the same thing as -2 to the exponent n minus 1. Okay. Well, these are almost, remember, solving equations, you want your left side to be equal to your right side, and these are almost identical. Look, same base, same base. It's just my exponent. So what would I need to plug in for n in order for it to work out to an 11, and then my left side and my right side would be the same. So 11 equals n minus 1, add 1, n equals 12. And you might have been able to see that without doing any of that work. So it must be 12 terms then that are happening here. Okay, let's try this one. So A is 31250. And then I think I'm dividing by 3, but let me just check. 31250 divided by 3. Nope. Well, let me go the other way. 1250 divided by 6250 equals 0.2. Okay. 6250 divided by 31250, 0.2. So R is 0.2, and then Tn equals 0.4. And if I put this into my formula, this is what I get. So 0.4 divided by 31250 is where we're going to start. I'm going to divide this by 31250. 31250. And that gives me 0.0000128 equals 0.2 and minus 1. All right, let's change this number to a 0.2 to something. So I know it seems strange, but in my calculator, I'm going to go 0.2 times 0.2, and I get 0.04, so not small enough yet. So times 0.2, nope, still not small enough. Times 0.2, well, I'm getting closer, but still not there. Times 0.2, whoops. So after 5 times, I'm at 0.0032. So another time, 6. Oh, I'm getting really close. 7. Oh, well, there it is, 7. So if I go 0.2 times 0.2 times 0.2 times 0.2, oh, in my calculator, 7 times, I get this same decimal. All right, so now these look pretty identical, left side, right side. The only thing is I got to think what I'm going to put in for n so that these two sides are identical. And if I add 1, I get 8. So n must be 8. So there must be 8 terms that are happening in between here and here. Okay. Now, let's say we have this sequence. So consider this sequence. To determine the value of n, Tn equals 32. So actually, this is very similar to what we just did. A equals 0.125. R looks like it's equal to a -2 because it goes positive, negative, positive, and it's doubling each time. And then Tn equals 32. So I guess really this is just a continuation of what we were just doing. Divide each side by 0.125. 32 divided by 0.125 equals 256. -2 to the n minus 1. All right, so let's start. -2 times -2 times -2 I know is -8. That's 3. Times -2 times -2, that's 5. And that gives me -32. Times -2, 6, 7, 8. So this looks like it's -2 to the power 8. -2 to the n minus 1. And again, our bases are the same, it's just our exponents. I have to think about what am I going to put in for n in order to make left side equal right side. So I'm just going to put those exponents equal to each other. And n equals 9. So there must be 9 terms. All right, so one more problem to look at. What if we had x minus 7, x plus 2, 5x minus 2 as our 3 terms? And I know that's certainly weird because they're algebraic. Can we figure out what our possible values of x are? Okay, this is where we want to use what we know about ratios. So we know with ratios, we can divide 2 consecutive terms. And it would give us our value r. So if I had these 3 terms, I should be able to go 5x minus 2 divided by x plus 2, and I'll get some ratio. Same thing, I could have taken x plus 2, and I could have divided it by x minus 7 and get a ratio. So either one of those would have given me the same ratio. Well, since they give me the same ratio, then I should be able to put these equal to each other. And if I put them equal to each other, I can solve by cross multiplication. So x minus 7, 5x minus 2 should equal out to x plus 2, x plus 2. Okay, so let's expand this out using our distributive property. So we're going to multiply, so that gives me 5x squared minus 2x minus 35x plus 14 equals x squared plus 2x plus 2x plus 4. So 5x squared minus 37x plus 14 is equal to x squared plus 4x plus 4. All right, so then I'm going to move all my terms onto one side. So 5x squared, I'm going to bring that x squared over. It's going to become a negative x squared. And negative 37x minus 4x plus 14 minus 4. And that equals to 0. So I moved everything over onto the left. So I have 4x squared minus 41x plus 10 equals 0. And then from here, I want to factor this. Okay, so I'm going to use decomposition. I'm going to multiply the 4 by the 10, gives me 40. And my middle term is a negative 41. So if I multiply by 40 and 1, just a sec. Then I know if I multiply by a negative 40 and a negative 1 that I will end up with positive 40 if I multiply them together and negative 41 if I add them together. So I'm going to replace my middle term, 4x squared plus 40. Oops, sorry, it should be minus 40x. 4x squared minus 40x minus 1x plus 10 equals 0. And then bracket, 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 bracket. I'm going to take out a 4x, which leaves me with x minus 10. Take a negative 1, which leaves me with x minus 10. So 4x minus 1 and x minus 10. All right, so we're almost there. Now you need just to take each set of brackets and set them equal to 0 to solve for x. So that negative 1 will go to the other side, become a positive 1, divide by 4, divide by 4. So x is equal to 1/4. Or on this side, I'm going to add 10 to each side. X equals 10. There are my two solutions. So this is a huge problem. It starts by setting up our ratios and putting them equal to each other. Cross multiplication, we get binomials. And then from our binomials, we have to expand them out, move everything over to one side, factor it, and then solve for x. It's huge. Here's just another one. It's the exact same thing as what we did problem before. So 10 minus y divided by y plus 4 should be the same thing as if I took y plus 4 and divided it by 4y plus 1. And then cross multiply, and you get 10 minus y, 4y plus 1 equals y plus 4, y plus 4. And this gives me 40y plus 10 minus 4y squared minus y equals y squared plus 4y plus 4y plus 16. And then if I move everything over onto one side, I'm going to put my negative 4y squared first, minus y squared. And then I have 40y minus y minus 4y minus 4y. And then plus 10 minus 16 equals 0. So everything onto one side. And that gives me negative 5y squared. 40 minus 1 is 39. Minus 8 is 31. So a positive 31y. And then 10 minus 16 is negative 6. All right. So I'm actually going to take out a negative 1. Makes it easier for me to figure out my numbers. if I take out a -1, it changes all my signs, all my signs. So that becomes a positive 5y squared, -31, +6. Okay, two numbers that multiply to 30, but add together give me -31, are going to be a -30 and a -1. So 5y squared minus 30y minus 1y plus 6, bracket, 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 5y, y minus 6, -1, y minus 6. And that brings me to 5y minus 1, with that -1 out front, y minus 6 equals 0. So 5y minus 1 equals 0, which is going to be 5y equals 1, y equals a fifth. And over here we have y minus 6 equals 0, so y equals 6. So there you go. Once you do a couple of these, then they just kind of come second nature to you. But I always like it when we can add in other skills from other chapters in order to get this done. Okay, well, that brings us to the end of geometric sequences, a little bit of practice, and as always, if you have questions, definitely come see me.